just like everything else with logarithmic functions in pre-calculus, we're going to assume that you have seen these before. So my discussion of what a logarithm is will be somewhat briefer. If you need more help with logarithms, you should consult an Algebra 2 source rather than pre-calculus. I will talk about evaluating them then by hand. Not all logarithm expressions can be evaluated by hand. Not the way I mean anyway. But there will be some that you need on your calculator. I'll make sure to indicate which are which before I give you any such examples. When you graph basic logarithms, we'll do that next. We'll have a couple with no transformations, and then I'll show you how to graph logarithms with transformation. This is all things that you should have already seen in Algebra 2, so we're going to cover them all in one lesson, though, rather than several lessons. So what is a logarithm? The most important thing to remember about logarithms is that they were created specifically to be the inverse of exponential functions. So we just covered exponential functions, and now we do logarithms because they're opposites. When you take an exponential expression like 2 to the third power, that's 2 times 2 times 2, it equals 8. The equivalent logarithm expression is something you apply to the 8 to get back to the 2. Sorry, to get back to the 3, the exponent, the unknown exponent. So for a logarithm then, the base in your logarithm is the same as the base in the exponent. That's why it has the same name. It's the base. Log base 2. The argument for a logarithm is the answer to the power. So 8 is the answer to the power. So really this logarithm says, what power will I need to stick on this base, this 2, in order to get this answer, 8? So the logarithm asks that question. It's looking for the exponent. What power do I stick on 2 to get 8? So the answer to a logarithm is always that exponent, 3. Log base 2 of 8 is 3 because 2 to the third power is 8. It's meant to solve the equation 2 to the x equals 8. That's why we created this notation, was to express, well, how do we evaluate this backwards? So what power do I stick on 2 to get 8? Well, it's x. We'll find it at some point. But that's the unknown. We're trying to solve for it. That's what logarithms are for. So when you evaluate one of these by hand, you want to ask the question. The question the logarithm asks. What power do I stick on this base to get this answer? For example, log base 2 of 16. Well, 2 times 2 is 4. Times 2 again is 8. And then times 2 is 16. That's 4 2's. So 16 is 2 to the 4th power. And the answer is the exponent, 4. If I say log base 5 of 1 over 125, well, 125 is 5 times 5 times 5. But in order to turn it upside down, make the reciprocal, I need a negative exponent. So this one's going to be negative 3, because 5 times 5 times 5 is 125. A negative to make it upside down. Log base 3 of 1 over 27. Very similar idea. 27 is 3 times 3 times 3. That's 3. But to make 1 27th, I need negative 3 again. Same answer twice in a row. Log base 17 of 17. What power do I stick on 17 in order to get 17? Well, 17 is 17 to the first power. You should also keep in mind that it doesn't really matter what base you have. In order to get, in order to get 1, you have to use an exponent of 0. Anything to the 0th power is 1. The other one you'll want to remember is, since they are inverses, 22 to the log base 22 of anything, like say 15, is going to be that thing. These are opposites, they cancel. If you want to unpack that a little bit, logically speaking, here you're asking, well, what power do I stick on 22 to get 15? Now once you find that number, which is irrational, but the power that you stick on 22 to get 15, if you stick that on 22, you'd better get 15. I'll say that again. If you find the power that you can stick on 22 to get 15, When you stick it on 22, you should get 15. It's probably easier just to remember their opposites and they cancel. Similarly, if you do log base 5 of 5 to the 8th, what power do you stick on 5 to get 5 to the 8th? Well, 8, because it's 5 to the 8th. So they're opposites, so as long as they have the same base, the exponent of a logarithm, so, an exponent that is a logarithm will cancel if they have the same base, and a logarithm of an exponent will cancel. Or I should say of a power. Well, if they have the same base, they will cancel. So these are the ones you can do by hand. Logarithms that do not work out nicely. Well, like this one, log base 22 of 15. 15 is not a power of 22, not a whole number power of 22 anyway. So you'll need a calculator to evaluate things like that. This one worked out to be 8, but if this were 4 to the 8th, it's not going to work out nicely. You're going to need a calculator. Okay, graphing basic logarithm functions. The most basic one I can think of is log base 2 of x. So we'll start there. Because this is the inverse of 2 to the x, we can expect that the graph will have some similarities to the graph of y equals 2 to the x, which, if you'll remember, was a swoosh like so, where it went through 0, 1, and 1, 2, and curved up toward infinity over here pretty steeply and had a horizontal asymptote over here. So we're looking for a similar shape, but reflected over onto its side. So we're expecting a vertical asymptote, and we're expecting when it's done, instead of going up, it's going to go off to the right. So let me find a few points on here. Firstly, as I said, if there's a 1 here, no, XY chart. The power I stick on 2 to get 1 is going to be 0, because anything to the 0 power is 1. So 1 zeros on my graph. If I stick in a 2, I'll get 2 log base 2 of 2. What power do I stick on 2 to get 2? And the answer is 1. Now, really, when I do these and I need more points, I actually do these a little bit backwards. I think about powers of 2, and those are what you're going to want to stick in. The next power of 2 is 4. That's 2 squared. So what power do you stick on 2 to get 4? 2. And the next one will be 2 cubed, which is 8, which I won't graph. 4, 5, 6. Oh, I guess I can. So here we see the top half of this graph. And I could find points down here. They're going to be fractions, like 1/2, which, sorry. Oh, x should be 1/2. What power do you stick on 2 to get 1/2? The answer is -1. This is actually going to go down, and this is where we're going to get our vertical asymptote. So the basic logarithmic graph has a vertical asymptote at x equals 0, heads up, and then off to the right. And you can find the points by using powers of the base. I'm going to show you what happens when your base is less than 1, because it's going to flip the graph around. So for my next trick, I will graph log base 1/3 of x. Well, that's a base. I suppose I drew it a little bit big. Let me rewrite it. Y equals nice big log. Clearly the 1/3 is base, and there's my x. All right, that makes me feel better. So when I make my xy chart, 1 is still the easiest one. Anything to the 0 power is 1. So it's going to go through 1, 0 again. But if I stick in 3 here, that's actually the reciprocal of my base. So if I'm going to get 3 as my answer, I need -1 for the power. So when x is 3, the answer is -1. The next would be 9, which is -2. 7, 8, 9, which is way over here. So this one is going down to the right, or I should say down to, yeah, as it goes to the right. So the other end, as you might have already guessed, 1/3 is going to give me 1. It's the same as my base. And the next one would be 1/9, which would be the square, which is going to be about right there. So right there is my vertical asymptote going up. If the base is less than 1, it flips the graph upside down, and it comes down to the right. So these are our basic forms for the logarithms. We should be prepared to transform them. I'll do one of those, but frankly, you should be getting used to transforming graphs by now, so I'm not going to do a lot of them. Y equals 5 times the log base 4 of x plus 2 minus 2. So the first thing I'll note is the base is bigger than 1. I'm expecting this graph by default to go up and to the right. The plus 2 on the inside is going to move it left 2 spaces. So if I didn't know already, I would expect the vertical asymptote to move from 0, where it normally goes, 2 spaces to the left, and be over here at x equals -2. If you prefer, you can keep the mindset you're not allowed to stick 0 into a logarithm. There's no way to get 0 as the answer to an exponential function. So if you can't stick 0 in here, and the place where if you stuck it in you would get 0 is the place you'll have a vertical asymptote. So -2 is what makes the argument here 0, which is what makes the logarithm not work, produces the vertical asymptote. All right, as I start thinking through what's going on here then, I could start by remembering the point 1, 0 and transforming it, left 2 spaces, and then multiply it by 5, which won't change anything because vertical stretch on a point that's on the x-axis will not go anywhere. So I am going to end up at -1, -2. But I find it's easier for the logarithm to just find points. Find a couple of points. You only need 2 or 3 in order to be able to draw the graph. Remember, there's a vertical asymptote. Base is bigger than 1, so it's coming up. So 2 points to fix my curve should be enough. I'll probably do more than that. I want to make the argument 1 because 4 to the 0th power is 1. So to make that 1, I'll stick in -1. I stick in -1. This becomes log base 4 of 1, which is 0. 5 times 0 is 0. Minus 2 is -2. -1, -2, as promised. The next nice number is going to be where the inside is equal to 4, the same as my base. So for that, I need to stick in 2. When I stick in 2, I'll get log base 4 of 4, which is 1, times 5 is 5, minus 2 is 3. 2. So this one is going to take a lot longer to get shallow because the 5 is a vertical stretch. It's going to stretch it tall, so I need to go out quite a ways to get shallow. The next power of 4 would be 16, which is going to be well off this side of my graph. I'm not going to bother drawing it then, but let's see, that would be up at about 10. So 14, 8 actually, which there's no way that's going to fit. Although while I'm thinking about it, I'll put it over here. 14, that would give me log base 4 is 16, which is 2. 2 times 5 is 10. Minus 2 is 8. So there's my graph. Notice it's not nearly as sharp a turn over to the right because it's multiplied by 5. Shifted left 2 spaces, shifted down 2 spaces. Hopefully this will get you started on your homework. Please contact me if you have any questions at all.